Hey there. Today we're going to be building out our library for our organization. So what I have right now is a completely empty library, so we're going to be building up everything from scratch. Now, there's typically going to be two ways that you can make library parts. The first is going to be downloading a part that previously exists in the Artifacts public libraries. We have a ton of 38999s, M27500 for your shielded twisted cable, and then we also have 22759s for all of your single core, single conductor hookup wire. So if you look up a part and find it, and that's going to be anything with a purple globe icon, you can open that part up, see all the specs that we've added, and then hit this Add to My Library button, which you'll now see that part pop up in your local library that you can drag into a diagram canvas. Now, another way that you're typically going to be adding library parts is going to be adding it yourself. So right now I'm going to add a device. Now this is typically going to either be a PCB, a commercial off-the-shelf electrical box or LRU, it might be a sensor, it might be an actuator, basically some smart electrical thing. And what I'm going to do here is I'm just going to go ahead and start adding some ports here. So I'm just going to make a really simple device. I'm going to have, let's just say like two screw terminal pins for power, and let's just make that a 5-pin thing for, I don't know, like an RS422 bus. So what I'm going to do here is I'm going to create a new connector, and I'm just going to call that 2-pin screw terminal. Let's add 2 pins to it, and let's save the changes here and apply that. So now I'll see that screw pin terminal there, and let's call this guy V plus and ground. Now, I don't necessarily have to treat it as a connector. If I have something like flying leads, I can click on this little pin icon and change that to a flying lead, and then of course like set the color and all that good stuff. But in this case, I'm just going to have it as a standard screw terminal. Next, what I'm going to be doing is adding my serial cable. Let me actually add that just to specify power, and let's call that serial. And now I'm just going to have TX plus, TX minus, RX plus, and RX minus. Of course, you can do like the whole like tab, enter, shift, enter, as if you were navigating any other table. And let's also have a ground reference there. Now, for the mating connector here, I'm actually going to go pretty deep. So I'm going to specify the mating connector as just like a 4-pin Molex, but I'm also going to specify contact part numbers, and I'm also going to specify a crimp tool. So let's go ahead and do that. So I don't remember all the Molex part numbers off the top of my head, but let's just call it that, just to keep it easy. And we're going to add 4 pins there, and let's make a new contact as well. So I'm just going to call this male pin, and I'm also going to add my tool as well. So I'm just going to call this my Molex crimp tool. You can also do nested tools. So if you have something like an AFM8 and you have a turret, you can link the turret to the actual crimp tool. So anytime you have a pin and you bring in the turret, it'll automatically bring the crimp tool as well. So let's save the changes, apply the tool. So that's going to be at the pin level. And now what I'm going to do is apply that pin to every pin in this connector. Let's also add a back shell while we're here too. So I know Molexes typically don't have a back shell, but I'm just going to include it for sake of example here. So now I have a connector. It's my 4-pin Molex. It's got all these contacts in it. It has this back shell. I can add extra accessories if I want to, things like strain relief, whatever it might be. I don't have it in this case. And here you'll see the tools that it inherited from these male pins here. So now I'm going to go ahead and hit the Save Changes button, apply it. So now I know that I have this 4-pin connector on my, I guess, like 5-pin device. So let me actually remove these access pins. I'm glad it caught it for me. And then I'm going to update the pin contacts to then pull from this connector level. So forget the ground reference. We'll ignore that for now. And now if I scroll down, I'll also see, like I mentioned earlier at the connector level, at the device level, it's also brought in my crimp tools. It's also brought in my back shell. So anytime I bring in this device, I'll see all of those extra parts as well. Other things that we can do here, let's actually, I don't know, I'll call this my demo single board computer here for my part number. You can adjust spacing, all that good stuff, hide pins, mess around there. You can also add your different breadcrumbs. So let's actually put this in compute components. And what this is going to do is it's going to create a subfolder for this item. If I hit Save Changes, you'll see it there. You can also like drag and drop it into different subfolders, all the classic things that you'd expect there. If I scroll to the bottom here, I can also add my data sheet, so you can upload a file, but you can also add manufacturing part information. So if I fill in anything like unit costs, manufacturer, I can even add some serial numbers so I can serialize and trace things here too. All of that will get saved. And now if I exit out of this guy, because I started it, and I'll just make a little dummy diagram here, what I can do is drag this part in, and because I've defined all of the information at my library level, I'll see all that information that's relevant, including things like the Molex back shell, the crimp tools, all that good stuff, and also the mail pins here too. Going back to my library though, I talked about devices, we talked about connectors already. Let's add some cables here too. So there's typically going to be 3 types of cables that you might be interested in adding. Single conductor cable, which will just be like your traditional hookup wire. So if I wanted to add, let's just like add a thing of red wire here. I can set my insulation here. I can also set my gauge. And now if I go to a diagram, I can drag that in and I can see that wire. I can also, of course, create a wire from the diagram and then assign it this way too. Now, another type of cable that you might create is a multi-conductor cable. So let's do that next. So this is going to be like your typical M27500 style cable here, and let's make that guy shielded, and let's just use the M2700 color coding as well. So that's going to be white, blue, white, and then orange and white. Let's make all these guys 22 gauge as well. Same thing as before, you can add accessories and tools. Not going to do that this time around. And let's call this a 3-wire M27500. We also have this in the library, so it's a little redundant. But I'm going to go ahead and save these changes. And same thing as before, that's something that you can drag into your diagram as well. For inline components and terminals, we have a bunch of pre-existing symbols here that are custom. The ones that like we've seen people use the most are going to be like splices, where you can now like have one wire on one end going out to a bunch of wires on the other end of the splice. You can also create your own inline component here, or let's say that you have like a custom splice that your company is going to specifically be using. You can add that's part number here, change it to use the splice symbol, and of course I might add a new folder here for custom parts, just to keep it separate from the default components. You can add your gauge range, all that good stuff, and it's identically going to be for terminals as well. So this is going to be all of your ring terminals, your forks, your ferrules, all that good stuff. You can add custom components the same way that you have a custom inline. Accessories is just really going to be anything similar to contacts and back shells that you can drag into a library part. We already talked about contacts, back shells, and tools earlier as well. Perfect. Alrighty. Well, that's making your first set of library parts.